Assignment 5-1, question number 1. You need to write it down, and then I'm going to answer right in the book, but you need to write it down and answer it on your page. So this has to do with shells to be able to find the volume. And so the first concept is understanding the radius and the height for the shell. So if I look at this diagram, the radius is the x coordinate. If you like, it's the right subtract the left. So the radius subtract 0, or right subtract left. The radius is going to be x. The height is, again, top subtract bottom. The top of the height is this equation. Subtract 0 on the bottom. And that's it. For number 2, the radius, again, here's the radius, subtract 0. So it's just the x coordinate, subtract 0. The height, be careful here, it's top subtract bottom. So it's 0 subtract the curve. So we're still thinking of top subtract bottom or right subtract left. Here for the radius, it's in terms of y because of the direction it's going. So if you think of the y coordinate here, top subtract bottom, it's the y coordinate, subtract 0 or just y. And then the height would be right subtract left. So that would be 4 subtract what this is. Oh, and this needs to be written differently. So multiply by 2 both sides. So x is equal to 2y. So we need this value. So it's the right subtract the left. Done. In number 4, we're going to set up the integration doing the shell method. So let's just set it up 2 pi. We're going to integrate. It's parallel to the y. That means this is going to be in terms of it's parallel to the x. It should be this direction, right? No, this direction. All right. And then this can represent the height. It's my fault. This can represent the height, and then the radius. And so the radius is just the x coordinate. And the height is top subtract bottom, or 1 minus x subtract 0, and that's it. Oh, we're integrating from 0 to, what's this value? It's 1, right? Because 1 take away 1 is 0. Number 5. Again, using the shell method here. This represents the height. Now it's sideways, so it's going to be in terms of y because of the direction it's going. Still 2 pi. The y value, the bottom y to the top would be negative 2 to 0. The radius would be y, take away 0 or just y. And the height would be right subtract left. So I need to rearrange this. So I'm going to add x and subtract y. So it's going to be 4 subtract 2 minus y. You have your answer. Number 6. These are x's. I'll do that above here. It's 2 pi. Goes 0 to, I need to know that value. So it looks like it's 2. It is. The radius, just the x coordinate, and then top subtract bottom. So that's 8 subtract this. And there you go. Number 7. All right, I'm going to switch. So for number 7, you have y equals the square root of x. You have y equals 0. You have x equals 5. Revolved about the x-axis. This is the square root of x. Y equals 0 is the x-axis. And then x equals 5. So my bounds, using the shall method, so for number 7, if I'm revolving it around the x-axis, it's going to be the y values. So it goes 0 to the square root of, right? Let's make this look like x equals y squared. But anyways, if I plug in 5, it's the square root of 5. So it goes 0 to the square root of 5. All right, the y value is the radius. And then I go right, subtract left. And there's your answer. And it says don't integrate it. Number 8. All right, for these I need to find the volumes. So I'm going to graph it first. It's only in the first quadrant, so I just need to curve this up, and it's this area right in here. So you can see it goes from 0 and then 1, because if you plug in 1, you get the same answer. So 0 to 1, so it's 2 pi, 0 to 1. And I'm going to revolve it around the x-axis, so that means it's in terms of y. Oh, it says I can use any method. So if I could use any method here around the x-axis, I wouldn't use the shell method. Instead, along the x-axis, there's a space here, and so I'd use a washer method in terms of revolving around here. The first radius, the big radius, is the top subtract the bottom, which would just be x, and then the small radius would be the curve subtract 0, which is x cubed. And it says to actually find it. So, oh, and my integration again would be 0 to 1. So this is x squared minus x cubed. Well, actually cubed squared, so it's squared to the 6th. Multiply them together. And then I'm going to integrate. So add 1 to the exponent and divide. Add 1 to the exponent and divide from 0 to 1. Plug in 1 first. Subtract, plug in 0. If you really want, it's 7, take away 3. So it's 4 pi over 21. Like that. 7, take away 3 over 21. 4 pi over 21. Fun, right? Number 9. Y equals the square root of x plus 2. X equals 0 and y equals 0. X equals 4 around the y-axis. Graph this. So the square root of x plus 2 means it goes up to right here. X equals 0. Y equals 0. And x equals 4. This is going to be an example where the shell method's better because you'd have to set up 2 integrals if you did it the other way. And so we're going around which axis? Around the y-axis. So it's parallel to the y. So if I revolve it around the y-axis, I'm going to use the x values for that. And so this is the region here. And so the radius is just the x coordinate, and the height here of it is top subtract bottom, which is the square root of x plus 2 take away 0. And it's bounded from 0 to 4. I'm going to multiply it. This is really x to the half, so if you multiply it, you add the exponents, so it's 3 over 2. Add 1, and then the reciprocal. Add 1, and then the reciprocal from 0 to 4. And then we plug in 4. And then when you plug in 0, it's 0. So there's your answer. If you simplify it, it's 288 pi over 5, but perfect. Number 10. I'm going to do this back in the book, but you need to write it down. It says give the radius and height of the shell formed in terms of what you're looking at here. So this, if it's around -1, we're going to go right, subtract left. So right is the x coordinate, subtract -1. So it ends up being x plus 1. The height is the top, subtract the bottom. So that's -2x plus 2, subtract 0, or just -2x plus 2. Here, the radius here, around this line, again, we're going to go right, subtract left. In this case, the left is just the x coordinate. The height here, the top, which is 0, subtract the bottom, which is the curve, x squared minus 2x. So right, subtract left, top, subtract bottom to find the values. The radius, right, subtract left. This is just the x coordinate. Oh, it's going the other direction. Ha. I didn't saw it in terms of sideways. So it is right, subtract left. So it is 2, subtract the y coordinate. The height, sorry, here, 2, subtract the y coordinate. So top, subtract bottom. Here, it's going to be 2, subtract the curve. Now this you have to change. So you have to cube both sides so that x is equal to y cubed. This is what I'm going to use. So now it is right, subtract left. Done. Number 13. We're setting up integrals, and we can use any method we want to find it. So we have y equals x squared, that's the curve underneath. 4x negative x squared is the one that's concave down. And it says use any method. So if it's around the x one, I see a space here. I'm going to revolve it using a washer. Now we have to find the bounds. And so this bound down here is 0. The other bound we'd have to make equal to each other. And then solve it. So I'm going to add x squared and subtract 4x. I'm going to factor out. And you can see the answers are 0 and 2. All right. So the big radius is the top, subtract the bottom, which is 0. So that's 4x minus x squared, take away 0. I don't need to go take away 0. And then the small radius, that's the small radius. This is the big radius. The small radius is the second curve, x squared, take away 0. Or just x squared. About the line x equals 4, which is up here. And again, I'm just going to use a washer here. So now the big radius is 4, take away the bottom curve, which is x squared. And then the little radius is 4, take away the negative. So top subtract bottom for the big radius and small radius. About x equals -1, that's below. I'm just more comfortable with washers than shells, but we're going to practice both there when it's necessary. So it still goes 0 to 2. So for this line down here at -1, the big radius goes 4x minus x squared subtract -1. And the little radius here is x squared subtract -1. And there it is. For problems 16 and 17, draw accurate sketches and set up integrals, but don't integrate, which could be used to find the volumes formed revolving the plane of region bounded by that and that around what it's saying. So I'm going to do that over here. So we have x equals y subtract y squared, and y equals 2. No, x equals 0. So let's start there. I'm going to factor this. And so my two answers are 0 and +1 on the y. And I know the shape of this is a sideways parabola. And the second one is just, x equals 0. That's this right here. So this is the area right here that we're talking about. And it says first, use y equals 2 and revolve around y equals 2. So if I revolve it around there, I'm going to use a washer because it's a little bit easier. Because otherwise I'd have to solve for y, and that's not simple here. I'd have to use the quadratic formula to solve for y. So I don't want to do that in terms of what it's revolving around. So because it's revolving around y equals 2 like this is not set up easy to know what y equals. Because I need to know what y equals. I'd have to use the quadratic formula, and I don't want to do that. So we're going to use the shell method. And so to find it, it's 2 pi. We're going to go from 0 to 1. The radius is the y coordinate, but it's going to be top subtract bottom. So it's 2 subtract the y coordinate. And then the height of it goes sideways. So it's right subtract left. So it's 0 subtract that. Oh, yeah, right subtract left. Wait a second. I noticed something. Y squared is negative. So, can I redraw this for you? It's still at 0 and 1, but because it's negative, it goes in this direction. Everything's going to stay the same except one thing. This is the correct one. It goes in this direction. It's still 0 to 1. We still have this line of revolution. Still, everything's the same except this part. Right subtract left. So, if it's y subtract y squared, you'd subtract 0. And there it is. So I just have to be careful how I drew it so I know what right subtract left is. So this is no good. This is good. Number 17. Oh, the same one, but now around the line y equals -3. All right, so I still have to use it here. So 2 pi. The same radius, which is not the same radius. It's the y value subtract -3, because the y value is above and -3 is below. Or you could say y plus 3. And then the height is still right subtract left. And when you subtract 0, it's the same. And there it is. Number 18. It says set up integrals, don't integrate, which could be used to find the volumes formed by revolving. So we have y equals 1/2 x. We have y equals 0 and x equals 6. So let's start there. That's x equals 6. This is y equals 0. And then 1/2 means I go up 1 and over 2. And it says first I'm revolving which way? About the line y equals -2, which is down here. It says first use washers. So if I do that, it's a circle, pi r squared. The x values go 0 to 6. And we have 2 radii that we're subtracting. So the big radius goes from here to here. So the top of it is the line. Subtract the bottom of it, which is -2. The second radius, the small radius, goes from here to here. That is 0 subtract -2, or just 2. Part B says use shells. And again, this is going to be in terms of the y values because of it. So when I use shells, it's parallel to this. So you have to draw it parallel. So the y value here compared to here. So if I go 1/2, if I go 6 times 1/2, that's 3. So it goes 0 to 3. The radius is right subtract left. So that would be 6 subtract y. Oh, wait a second. The line of revolution right here. So I'm still going right subtract left for the height, but for the y coordinate, because it's below, it's the y value subtract -2. So the y value subtract -2. That's the radius. This is the height. Sorry, the right subtract the left. So that's 6 subtract, and I need to change this. So multiply times 2, and x is equal to 2y. So that would be 6 minus 2y, and that would be dy. Number 19. Find the volumes of solids formed by revolving the region y equals 1 over x squared, y equals 0. X equals 1, x equals 3. So 1x squared, it would also be on the other side, but we have y equals 0, x equals 1, x equals 3, and y equals 0. So it's this right here. And it says we're revolving it around, and so you may use a calculator. We're revolving it around the y-axis. So if I revolve it around the y-axis, I'm going to use the shell method here. So this is my height going up and down. So it goes 0 to 4. Oh, I need the y values. No, I'm sorry. It goes, what does it go? It goes 1 to 3. And the radius is the x-coordinate, subtract 0. And the height is the top, subtract the bottom. And the top is 1 over x squared, subtract 0 or that. And then if you type that in your calculator, you can do that. It's 6.902 or 3. So you can see if you can try it out. Type it in and see if you get that answer. In part B, it's about the line x equals 4. That's over here. So start it the same way. Now the x-coordinate, this is on the right, so it's going to be 4 subtract x. That's the radius. And then top subtract bottom again, which is 1 over x squared. And again, type that in your calculator, and you would get the answer 9.852 for the volume. 20. In number 20, it says find the length of the curve. So to find curve length, it's square root 1 plus the derivative squared. That's what I'm looking at. You just have to memorize it. And we're integrating. In this case, so there's the formula. So in our case, it's from 1 to 4, square root 1 plus, and it's the derivative. So that's 6x minus 2 squared dx. That's what we're doing. Use your calculator, and you get 39.141. Just type it in. 21. Find the curve length of one complete cycle of y equals cosine x. So one cycle goes 0 to 2 pi of cosine x. Oops. The formula is square root 1 plus, what's the derivative of cosine? It's negative sign, it's squared, so it doesn't really matter if it's negative. And then type that into your calculator. And one length is 7.640. All right, now's the rest of the review questions. 22. Integrate x minus 1 squared over x to 3 halves dx. I'm going to FOIL this, expand it. And then I'm going to write it as x squared over that minus 2x over that. So write it as 3 fractions. Subtract. 2 subtract 3 halves is a half. 1 subtract 3 halves is negative a half. And then this would just be negative 3 over 2. And then we add 1 to the exponent and divide, or the reciprocal. Add 1, divide, or the reciprocal. Add 1, or the reciprocal, plus c. And there you go. Number 23. And write this calculus friendly. Oh, negative a half, right? All right. So the hook should be negative 6x. So I need a negative 1/6 in front. Circle the hook and unhook it. Starts with negative 1/6. Add 1 to the exponent. And then the reciprocal plus c. Done. 24. When you integrate absolute value, you're graphing. So if I graph this, negative 4, that's negative 8 plus 6, That answer is going to be positive 2 when I do the absolute value. Put in negative 1 and you get positive 4. And then the vertex, if I find the 0 of this, so if I subtract 6 and divide by 2, the vertex is at negative 3. So it looks like this. And then there are 2 triangles to find the area of. This triangle, half the base times the height, and then half the base two, right? And the height, which we said was 4. So this is 1 plus 4, so that's, I think, 5. 25. The derivative of this is 1. They don't match. This is a u substitution question. So u is t plus 1. T is u minus 1, and dt is equal to du. There's a start. Take out t, put in u minus 1. Take out t plus 1, put in u. And dt is du. And then distribute. So we're going to add the exponents. And then I'm going to do the antiderivative. So I'm going to add 1 and then divide, or the reciprocal. Add 1 and the reciprocal. And then the last step is to put t plus 1 back in. Awesome. 26. It says set up, don't integrate, which can be used to find the area. So there's 2 equations. Negative x squared plus 1 and x squared minus 2x subtract 3. So I'm going to graph these and find the area trapped there. So negative x squared folds down and we go up 1. The second one, I'm going to factor it. So positive 3 and negative 1, and it folds up. And this is the area I'm finding. So I already know it's bounded on one side by negative 1. But I don't know this. So I'm going to make it equal to each other. And then solve it. So I'm going to add 2x squared, add 2x, add 3, divide everything by 2. So, oh, I did it wrong. So I add x squared, we have minus 2x, sorry, and subtract 1. I got my signs mixed up. So this should be negative x and this should be negative 2. So that when I factor it, it's negative 2 and positive 1. So if I solve it, it's positive 2 and negative 1. So I already saw that. So the other one to bound is 2, which makes sense looking off the graph. And then the top is negative x squared plus 1. Subtract the bottom, which is x squared minus 2x subtract 3 dx. And there it is. And it said don't actually integrate it, right? So that would be the area of it. 27. It's to sketch the region bounded by that and find the area of it. So x minus 2 means it's been shifted 2 to the right, and then it's the square root. X equals 6, so that's 3, 4, 5, 6. And then y equals 0. So this is the area. So this is an integration question that goes from 2 to 6. The top. Subtract the bottom, which is 0, and there's the setup. And then find the area of that. So write it calculus friendly. The hook is 1, which is there, so I just have to add 1 to the exponent, and then the reciprocal from 2 to 6. Plug in 6. Plug in 2, which will give me answer 0. So if I had to simplify it, 4, the square root of 4 is 2, and 2 cubes 8, so this is 16 over 3. 28. Use the region from 27, the one we just did. Find the volume of the solid form by using square cross sections, perpendicular. So we're going to still go 2 to 6. Square, that's the formula, and when I go top subtract bottom, it's the square root of x minus 2. So there's the setup. If you square it, it's just x minus 2. Integrate it, and then plug in. And that will give you the answer. So 36 take away divided by 2. 4 divided by 2, 4. So negative 4 take away 4. I get 16. What would I do? Get 8. Oh, 18 take away 12. This should be a 6. So this is 6 subtract negative 2, which is 8. Oh, yeah. Duh. All right, number 29. The base of the solid is the region bounded by y equals 1 over the square root of x. X equals 1, x equals 4, y equals negative 3. So if I plug in 1, the answer is 1. There's an asymptote here. If I plug in 4, the answer is a half. And then y equals negative 3. So that's the area, or that's the base. Rectangular cross sections. So we're using integration, and it's going from 1 to 4. The base of the rectangle is top subtract bottom. That's 1 over root x subtract negative 3. The height of the rectangle is 3 times the base. And then you would type that into your calculator. If you typed it in correctly, you get 121.159 or 158. Number 30. No calculator. What's the domain of this? Well, x has to be greater than or equal to 0. B, what are the x-intercepts? So 0 would give me the answer at add, square, subtract. So I added x, I squared both sides. Subtract 4x, factor, and I get the answer 0 and 4. C, the max. I got to take the derivative. So the derivative would be 1/2 times 2, which is 1. Subtract 1 to the exponent. And the derivative of negative x is negative 1 equal to 0. So this is 1 over the square root of x equals 1. So x is equal to 1. That's the answer. All right. This is 1 over the square root of x minus 1. So if I plug in 1/2, the answer is positive. If I plug in like 5 or 6 or something, the answer is negative. So this is a maximum at 1. And if I plug 1 in here, 2 take away 1 is 1. So 1, 1 is a maximum. D. Oh, what's the minimum values of it? So the maximum value is 1. It goes and then it goes down. I don't know if there's a minimum. There's no minimum value. Because it just goes down forever. So it goes down to negative infinity. So there's no minimum value. But there is a maximum value. So the actual value is 1 is the answer. The point is 1, 1 for the relative maximum. But the maximum value of the function is positive 1. D, what's the range? Oh, so the max value is 1. So the range goes negative infinity up to 1. Huh. There you go. I was trying to overthink it. 31. Show that the graph that we just did has no points of inflection by building a second derivative number line which indicates the concavity. So the second derivative using this would be negative 1/2 x, subtract 1 to the exponent and 0, make it equal to 0 and solve it, and you see the only answer there would be 0. Well, 0 is the beginning of the domain, and so no matter what number you put in here, the answer is always going to be negative, so it's only concave down. Only concave down. All right. In fact, this is a fraction, and it can't even equal 0, so there's no solution to it, so it's only concave down. All right, 32. Use the results from 30 and 31 to sketch a graph. Can it be? Oh, it can be 0. So these are the x-intercepts, the maximum, and it rises and then falls, and it's only concave down. 33. Integrate that. Good question. So I'm going to add 1 to the exponent and then do the reciprocal. Add 1 to the exponent and the divide, and it goes 0 to 4. I'm going to run out of space, but when you plug in 4, it's 4/3, 4 to the 3/2, minus 4 squared divided by 2. When you plug in 0, the answer is 0, so this would give you the answer. And if you simplified it, you get 8/3. $34. We can use that 8/3. Find the average value. That's an integration question from 0 to 4 divided by the bounds. So we just found this to be 8/3 divided by 4, so it's 8/12, or 3/4 is the average value. Is that right? Not 3. Divide by 4. 2/3. Haha. That's the average value. That's 8/12. 35, use a calculator to find the C value where the function equals the average value. So you take the function, make it equal to 2/3, use your calculator, and solve it. And if you did it correctly, you get the answer. 0.179. And the answer 2.488. There are two answers where the average value equals that. 36. Wow, I keep using it. Find the instantaneous rate of change at 2. So do the derivative. We already did the derivative. Plug in 2. So I have 1 over the square root of 2 minus 1. (37) Find the average rate of change. A-rock. This is such good practice. So that's the change in y over the change in x, or in this case, f at 4 subtract f at 0 divided by that. So if I plugged in 4, I get 2 times 2, which is 4. Take away 4, which is 0. If I plugged in 0, I get 0. So the average change is 0. F at x, is it continuous from 0 to 4 and differentiable from 0 to 4? The answer is yes. It is continuous and differentiable from 0 to 4. And you can look off the graph, right, to sense that from 0 to 4, it's differentiable and continuous. So if your answer is yes, then the MVT guarantees a point, right? So then we take the 0, the average rate of change, equal to the derivative, and then we solve it. So we add 1. This is 1 over the square root of x. Multiply by the square root of x, and you can see x is equal to positive 1. And that would be the C value, where the average rate of change equals the instantaneous rate of change from 0 to 4. And that's it. You did your homework. I am so proud of you. Mr. G Math, over and out.